Okay, so this first lesson is about crude oil and alkanes. So fundamentally, all organic chemistry stems from crude oil. Okay, so that's our starting point. So if we have crude oil, everything that we're going to talk about in this entire topic comes from crude oil originally. So crude oil is something you might have heard of before, something you might have come across. Fundamentally, it's a fossil fuel. So we would come across it as an example of a fossil fuel, just like coal, natural gas, crude oil. They're the main fossil fuels you need to know. Now, the fact that it's fossil fuel kind of gives us a hint as to how it's made. Okay, if we think about what fossils are, fossils are the remains of prehistoric creatures. Okay, so we know it has something to do with the remains of living organisms. So we're just going to flow map the formation of crude oil, and I think that one of the big misconceptions here that everyone thinks is, crude oil, that's dinosaurs, that's, the dinosaurs died, the dinosaurs became fossil fuels, but it's not quite as exciting as that. So we're not talking about large organisms, we're talking about actually tiny microscopic organisms, but in large amounts. So the first thing in the formation of crude oil, we have microorganisms die and fall to the seabed. Okay, so we're not talking about dinosaurs. We're talking most likely about phytoplankton, zooplankton, very, very primitive, very, very small microorganisms. Okay, so they die and they fall to the seabed. And once they land on the seabed, they're going to become trapped under layers of sediment. So the layers of sand, silt and sediment are going to build up on top of our dead microorganisms. And what that does is two things. Number one, it puts them under immense pressure. You're also creating an environment where there's no oxygen, so no oxygen can get into the organisms. So if there's no oxygen, they can't decompose, so that's quite important. So they're trapped under high pressure with no oxygen, and because of the depth, they're quite close to the mantle, so there's also quite a lot of heat. So under high heat, pressure, and with no oxygen, that's quite important. Only under those conditions are they able to form into crude oil. And again, this takes a long time, okay? So over millions of years. This will form crude oil. So we can add our boxes now. So again, most flow maps you should always try and do into 4 steps. So our microorganisms, our prehistoric microorganisms die, fall to the seabed, become trapped under layers of sediment and under high heat and pressure with no oxygen, and over millions of years they will form crude oil. So we know this now, when organisms die, they don't necessarily become fossil fuels. You need a large amount, so a large volume of dead organisms, and again, under very specific conditions over a very, very long period of time. So this crude oil, we extract it, okay? So we extract it from underground. It's found in underground caverns, and we drill down and we're able to extract this crude oil. But all of the things that we get from crude oil are incredibly useful. I'm sure you've heard of it. It's a very, very valuable commodity. Some of the things that we talk about that come from crude oil, petrol, diesel, liquid petroleum gases, really, really high demand substances. But crude oil itself, if we bought a barrel of it, would be pretty useless on its own, okay? Because it's a mixture, okay? So as a mixture, it's really not very useful, and we need to actually separate that mixture. So it's important to know that crude oil is a mixture of what we call saturated hydrocarbons. These are two very key words, saturated hydrocarbons. Now, the collective term that we use to describe saturated hydrocarbons is alkanes. Okay? You need to get used to using this vocabulary. You need to understand what saturated means, what hydrocarbons means, and that if we have saturated hydrocarbons, we call them alkanes. So, our definitions in terms of hydrocarbon is reasonably simple. It's a molecule that contains hydrogen and carbon only, nothing else. So a molecule that contains hydrogen and carbon only. So that's really key. Usually, to find a hydrocarbon is worth 2 marks, one for saying that it contains hydrogen and carbon, and the second mark for saying only. In terms of it being saturated, what we mean by that is it does not contain a double bond. So we need to talk about really what they are. So they're hydrocarbons, they only contain carbon and hydrogen. So if we give some examples, okay, so if we have methane, methane is a hydrocarbon because it only contains carbon and hydrogen, okay? So this is a hydrocarbon, and it doesn't contain any double bonds. So it's a saturated hydrocarbon, okay? If we have ethane, again, only contains carbon and hydrogen, and it doesn't contain any double bonds, so it's a saturated hydrocarbon. This is also an alkane. So these two here are alkanes. If we draw another one, this is ethene. So this is still a hydrocarbon because it's a molecule that only contains carbon and hydrogen. However, it has a double bond. So this is an unsaturated hydrocarbon, and we call this an alkene. And finally, if we have ethanol, very quickly we can see carbon, hydrogen, but here we have oxygen, so this one is not a hydrocarbon. It's still an organic molecule, but it's not a hydrocarbon, okay? So we have saturated hydrocarbons, unsaturated hydrocarbons, because they have a double bond, and then over here, this isn't a hydrocarbon at all. So you need to be able to name, draw, and describe different hydrocarbon molecules. So if in crude oil it only contains alkanes, so every one of those molecules in the mixture contains only carbon and hydrogen, nothing else. and they don't have any double bonds, they've only got single bonds, then the only thing that can possibly be different about them is the number of carbons that they have in the molecule. So when we're looking at alkanes, you'll notice that as we're going down, we're increasing the number of carbons. So these are all different alkane molecules. They are all different saturated hydrocarbons. But because they're all alkanes, so they're all saturated, all hydrocarbons, then they're going to basically be the same. They're going to all contain single bonds. They're going to all contain just carbon and hydrogen. The only thing that's going to change is the number of carbon atoms. We've got 1, 2, 3, 4, 5, and that continues. This is just where we've drawn the line. You get alkanes with hundreds of carbons. So we'll start with the displayed formula. So methane has 1 carbon. So we're going to put 1 carbon in the middle there. Ethane has 2 carbons. So we're going to put 2 carbons in the middle with a single bond. And we know it's a single bond because it's an alkane, and alkanes do not contain double bonds. Propane has 3 carbons. So 1, 2, 3, all single bonds because it's an alkane. And butane, again, it's going to have 4 carbons. 1, 2, 3, 4. And pentane has 5 carbons. 1, 2, 3, 4, 5. Now, in terms of working out how many hydrogens they have, this is where we're going to tie back into topic 2, covalent bonding. So we should know that carbon has 4 electrons in the outer shell, so it can form 4 covalent bonds. And that's precisely what it's going to do. And we know, because it's a saturated hydrocarbon, the only thing it can possibly bond to is hydrogen. So we're going to have 1, 2, 3, 4 covalent bonds to hydrogen atoms. This carbon here, again, can form 4 covalent bonds, but it's already made 1, so it only needs to make another 3, and now it's got 4, again, to hydrogen atoms. This carbon here already has 1, and is going to form 1, 2, 3 to other hydrogen atoms. In propane, this one on the end here, it's already got 1 bond, so it only needs to form another 3 to get the 4 covalent bonds that it wants. This carbon's already got 2, so it only needs 2 more to get all the covalent bonds that it wants. And this one on the end here needs another 3. And it's the same with butane. The one on the end needs 3, all of the others need 2, and then this one on the end also needs 3. So when you finish with your molecule, just double check. Do all of your hydrogens have 1 bond? Do all of your carbons have 4 bonds? And again, this ties into what we were doing with the covalent bonding in topic 2. So we'll just add our hydrogens in here. So, in terms of their molecular formula, it's just how many carbons, how many hydrogens. So this has 1 carbon, 4 hydrogens. This one here, 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens. 3 carbons, 8 hydrogens. 4 carbons, 10 hydrogens. 5 carbons, 12 hydrogens. So what you should be able to see is that they are following a pattern. Okay, and it says it down here. Explain why the general formula of the alkane is CnH2n plus 2. So you can see that for every carbon you have, you get twice as many hydrogens plus 2. So if you actually look at them, you'll notice that the minimum number of hydrogens they all have is 2. So for every carbon, you're guaranteed in an alkane, because they're all alkanes, that's the reason they follow this trend, every single carbon has a minimum of 2 hydrogens attached to it, with the exception of the ones on the end, which have an extra hydrogen attached, which is where that plus 2 comes from. So if every carbon has a minimum of 2 hydrogens, and then the 2 on the end have an extra hydrogen, that's where this formula comes in. And every single alkane will follow this general formula. So as long as you know how many carbons are in that alkane, you can apply this formula and you'll be able to work out its how many hydrogens it has. Okay, so you need to make sure that you know this. For alkanes, CnH2n plus 2. Make sure you learn that formula. So another thing we need to take away from this is the name. The name is really important because when you name organic molecules, it tells you what the molecule is like. It tells you what bonds it has, it tells you what atoms it has, it tells you how many as well. So we knew that this was one carbon because of this column here, but you actually did not need this column at all. We would have been able to work out how many carbons each molecule had and what kind of bonds it had just from the name. So you'll notice these are all alkanes and they all end in ane. Methane, ethane, propane, butane, pentane. All alkanes end in the word ane, and that tells you it's an alkane. If it ends in ene, it tells you it's an alkene. If we go back very quickly, I have methane, ethane, both alkanes. This is ethene, which is an alkene. This is ethanol, which is an alcohol. You don't need to know about alcohols, but the point is the end of the name told us what it was. If it ends in ane, it's an alkane. If it ends in ene, it's an alkene. If it ends in anol, it's an alcohol. So we already knew without being told, so we didn't need to know that it was an alkane because we can see from the name, ends in ane, must be an alkane. And we know that alkanes are saturated hydrocarbons. So we already knew that it would only contain carbon and hydrogen and it would only contain single bonds. The other thing they told us was this bit here. Meth. Eth. Prop. Bute. Pent. In organic chemistry, if a molecule begins with the word meth, that means it's got one carbon. If it begins with eth, that means it's got two carbons. If it begins with prop, it means it's got 3 carbons. Bute means it's got 4 carbons. And pent, I'm sure you've come across pentagons, 5 carbons. So if we had an alkane with 6 carbons, it would be hexane. If we had an alkane that had 10 carbons, it would be decane. So the beginning of the word tells you how many carbons. So the only ones you need to remember are the first 4. If it's got 1 carbon, it begins with meth. If it's got 2 carbons, it begins with eth, 3 carbons prop, and 4 carbons bute. Meth, eth, prop, bute. Okay? So if I had an alkene with 3 carbons, it would be propene. If I had an alkene with 4 carbons, it would be butene. If I had an alkane with 1 carbon, it would be methane. So the beginning of the word tells you how many carbons it has, and the ending of the word tells you what kind of molecule it is. So you need to make sure you remember 1 is meth, 2 is eth, 3 is prop, 4 is bute. Okay, now the mnemonic I've always used for this is monkeys, eat, peeled, bananas. Okay, 1, 2, 3, 4, meth, eth, prop, bute, and it refers to the number of carbons. So, what happens to the formula every time you add another carbon atom? Well, every time the number of carbons increases by 1, the hydrogens increases by 2. So increasing number of carbons by 1 increases number of hydrogens by 2. And explain why the general formula for an alkane is CnH2n plus 2. Okay? Because they are all saturated hydrocarbons. Therefore, every carbon has 2 hydrogens attached, which explains the H2n. And the 2 carbons on the end, on each end, have an additional hydrogen, which is why we have the plus 2. So because they are all saturated hydrocarbons, because they are all alkanes, they all follow this general formula, every single one of them. So if you know it's an alkane because it ends in ane, and you know how many carbons are in it because you know the prefix, or maybe you've been told, then immediately you can work out the formula because it will always follow this pattern here. Okay, now what I would like you to do is to work through these questions. Have a quick read of this. It gives you some more information about crude oil, and this image is useful, right? Refer back to it. I know the questions are on the next page, but refer back to this. It will help you answer those questions. Okay, and these are the questions I would like you to answer. And there will be answers and mark schemes put on to Show My Homework at a later date. And just before I finish, just make sure that you, on Show My Homework, you respond to this lesson. You can just leave a comment, just saying yes, or finished. It doesn't have to be any more information than that, just some sort of proof that you have actually accessed the resources, just so that we can keep tabs on who is and isn't following along with the online learning.